everybody. So continuing on our trig graph lesson, we're going to be modeling trig graphs. What that means is today we are going to be looking at word problems. Okay, so to start, the do now says define the following terms. Now, a period is the time or distance on the x-axis to complete one. Oh no, that's not what I wanted to do. Let me just space this out a little bit more. To complete one full cycle. Okay? So I am going to talk about that a little bit more, just to talk about the two graphs. We have a sine graph. I'll do this up here. We have a sine graph where if this is our midline, sine graph starts at the midline, goes above, goes below, and ends. So this ending point would be the period of our graph. Now for cosine, this is our midline. Cosine starts above, goes below, and ends above. So this here, whatever that point would be our period. Okay, so moving on. Frequency is number of cycles. I'm sorry, I should say full cycles. Number of full cycles in a given interval. The amplitude is the distance from midline to max or min. So looking at what we have here, the amplitude would be this distance. So this distance, or any of these. Okay, moving on. The midline is just the middle of the graph. And lastly, a cycle. What a cycle is one full rotation, or one full, let's say, graph. And in parentheses, I'll write rotation of graph. So a cycle is one full graph, either sine or one full cosine graph. Moving right along, we are going to be modeling situations using sinusoidal graphs. In doing so, we must identify key information. So we are going to have word problems, so you're going to need to know keywords in order to find the amplitude, period, frequency, etc. But first, let's review. So first, the relationship between period and frequency. There's a formula for this. The formula was P, which is the period, is equal to 2 pi divided by B, which is our frequency. How do we find the midline? If we know the highest and the lowest point. So to find the midline was represented as C, but it's usually in a y equals. You have to do the max, so that's the highest point, plus the min, which is the lowest point, and divide it by 2. And that will give you the midline. Decoding word problems. So there's pretty much 3 steps here. Now these steps are really just how to approach a word problem. First, as ridiculous as this sounds, read the whole problem to get a general understanding of what's being asked. If you don't read the problem through and through, you just look at the question, you will be missing some information. Annotate, just like you do in English. Underline and circle important information. So in this case, it's going to be key words that might give us information on the amplitude, period, etc. And lastly, solve what the problem is asking. So some key words, these are very important. For amplitude, you might see the words maximum and minimum. And for period, you might see the words every rotation, every cycle, wavelength, or anything along those lines. Because remember, a period is the time it takes to finish one full cycle or one full rotation. Okay, so let's look at the first example. It says the tides in a particular bay can be modeled with the equation in this form. So it's a cosine graph where T represents the number of hours since high tide and D represents the depth of the water in the bay. The maximum depth, so right here I see the word maximum, is 36 feet. The minimum depth is 22 feet. And the high tide hits every 12 hours. So the 3 things I circled are 3 key words. So this maximum and minimum, this helps us find the midline. This every is a key word for the period. Okay? So here it says on the axis, sketch a graph of this scenario for 2 full periods. Label the points on the curve that represent high and low tide. And part B says determine the values of A, B, and C in the model. Now what we can just do is we can go to B and then sketch it for A. So I would prefer doing that just because I would like to know what A, B, and C are before I get to the graph. So let's start with B. I'm going to start with the formula they give us, D equals A cosine B T plus C. So 3 things we need to find. We need to find A, B, and C. A is our amplitude, B is our frequency, C is our midline. We were given the maximum and the minimum. So what I suggest to do is let's start finding the midline. So to find the midline, we do max plus min divided by 2. The maximum was 36. The minimum was 22. We have to divide that by 2. Now we have to simplify this. So I'm going to pull up the calculator in case you need it. You can do this by hand if you'd like, but what you can also do is press alpha, y equals, to get it as a fraction, and you type in, what did we have, 36 plus 22 divided by 2. And we get 29. So we have that the midline now is 29. Now to find B. We know the period. This keyword, every, tells us that our period is 12. So what we can use to find B is the equation P equals 2 pi divided by B. Okay? When we do that, the period was 12 because they told us that from the question. So 12 is equal to 2 pi divided by B. We do need to cross multiply, but we need two fractions, so we're going to put the 12 over 1. And now we have 12 times b, which is 12b. And then we have 2 pi times 1, which is just 2 pi. To solve for b, we need to divide both sides by 12. The 12s cancel, and we're left with b is equal to, we can simplify this. 2 divided by 12. You can use your calculator if you want to use it. Press alpha, y equals 2 over 12. And it becomes 1/6. I didn't type the pi in the calculator because we want the pi in our answer. So 1 over 6 pi. And you don't necessarily need this one, so you can erase it if you'd like. So now we have b. The last thing we have to find is the amplitude. To find the amplitude, that's the distance from the midline to the maximum or minimum. So we can do the maximum minus the midline. Or you can do the midline minus the minimum, whichever you prefer. Our maximum was 36. We have to subtract the midline, which was 29. When we do 36 minus 29, we get 7. Okay, so now we have all 3 pieces of information. We can finish writing our equation. So what I'm going to do is I'm going to make this smaller. Oh man. I'm going to make this smaller and I'm going to write the equation right underneath it. Okay? So our equation with all information in it is D equals A is 7, cosine, B is pi over 6, and C was 29. So here is our equation. Okay, but now we still have to sketch this. Now, since it's a sketch, you don't need all of your numbers in there. You don't need a specific number of boxes. You just need to sketch what we have here. So we first have that our midline is 29. So a midline of 29, I'm just going to guess where 29 will be because it's not exact. We don't need a scale, but I will label this 29, okay? Now, our maximum was 36, so I know I'm going to have to go up to 36. Our minimum was 22, so I know I'm going to have to go down to 22. All right? That's really all the numbers we need on our axis. Now, the only last thing we need to mark is what our period will be. But I'm going to do that after we sketch 2 cycles so I know exactly where to put it. So we have cosine. Cosine starts above, then it goes midline, below, midline, above. So I just completed 1 full cycle. So that means that this point here is going to be 12 because it's my period. Now I'm going to do 1 more. So we're at the max. So now we're going to go midline, below, midline, above. I just did a second cycle. And now another 12 hours has passed, which means that this should be 24. Now I did 2 full periods because that's what the question asked me to do, 2 full periods. So that is this problem. Okay, exercise number 2. The height of a yo-yo above the ground can be modeled using the equation h equals 1.75 cosine of pi t plus 2.25, where h represents the height of the yo-yo in feet above the ground, and t represents the time in seconds it was dropped from its maximum height. Determine the maximum and minimum heights the yo-yo reaches above the ground. So we're given this equation, okay? We need to find the maximum and the minimum heights. I'll just finish writing this. So the maximum height can be found by taking your midline, because you have to start at your midline, and adding the amplitude. So I'm going to go back for a second. If we didn't know that the maximum height was 36, but we knew our midline and our amplitude, this distance here is A. So if you take your midline and add your amplitude, that will give you your maximum. Similarly, if you take your midline and subtract your amplitude, that's how you will get the minimum. So going back here, if we wanted to find our minimum, which we will have to find, we have to do our midline minus the amplitude. Okay? So starting here, our maximum is equal to, the midline is 2.25, and our amplitude is 1.75. Okay, so our max is 2.25 plus 1.75, which gives us 4. Now, one thing about the word problem is we know the units. We know that it is feet, so we can include 4 feet here. So I'm going to box that as one of our answers. To find the minimum, we just have to subtract instead of add. So our midline was still 2.25. Our amplitude was 1.75. Going to the calculator. Now some tricks, you can scroll over, press enter, and it'll show back up. And we change the plus to minus, and we get 0.5. So our minimum is equal to 0.5 feet. That was a horrible box. All right, so that was part A. Now part B says, how much time does it take for the yo-yo to return to the maximum height for the first time? So think about a yo-yo, okay? If you have a yo-yo, you start, let's say this is the floor. You don't have to copy this down. This is the floor. This is your yo-yo. This is the starting position, and then it goes down, right? It reaches almost to the floor, and then it goes back up to maximum height. So the yo-yo actually follows this sine pattern like it told us. So we're looking for how long it takes to complete one full cycle of the yo-yo. So starting up, going down, and then going back up. That is one full cycle that we're looking for. That tells us that we want to find the period. So the question is asking for the period of the graph. Now remember, there's a formula we use for this, which is period equals 2 pi divided by the frequency. We don't know our period, but we know that our frequency is pi. So we're doing 2 pi divided by pi. The pi's will cancel, and we get that our period is 2. Now it actually does give us some unit. It says seconds here. The period is the time it takes, right? We're looking for time. So we can write that the period is 2 seconds. Okay, so you just need to figure out, what are you trying to find? Are you trying to find the midline, the maximum, the minimum, the period? and so forth. Okay, let's do one more. A Ferris wheel is constructed such that a person gets to go on the wheel at its lowest point, 5 feet above the ground. Okay, so lowest point is also kind of the same thing as saying minimum, so keep that in mind. And it reaches its highest point, so its maximum, at 130 feet above the ground. The amount of times it takes to complete one full rotation is 8 minutes. That tells us about the period, one full rotation. It's a key word. A person's vertical position, 8 minutes. So that just says that it takes 8 minutes to go around again. A person's vertical position, y, so that's saying what y is, can be modeled as a function of time in minutes since they boarded by the equation. So we're using a cosine graph. Sketch a graph of the person's vertical position for one cycle and determine the values of A, B, and C. So let's start. You can start sketching if you'd like. I usually like starting with writing the equation. So y equals A cosine B of t plus c. Let's actually sketch first. Let's see what this will be like. We know our highest point is 130. We know our lowest point is 5. Now, we do need a midline for this, so we can start finding some information for this graph. So we are going to need to find A, B, and C. In order to sketch, we need to know our midline because we need to know what the middle of this graph is. So to find the midline, we do 130 plus 5 divided by 2. So the maximum plus the minimum divided by 2. You can use your calculators. Alpha y equals 130 plus 5 divided by 2. And we get 135 divided by 2. It doesn't come out to be a whole number, so you can change it to a decimal. To get it in a decimal, you can either retype it or you can press math and then dec. So it's 67.5. So this right here is 67.5. So that's our midline, 67.5. Now we can sketch it, okay? So the person starts at its lowest point. So the graph is actually going to start down here because you cannot get on the Ferris wheel at 130 feet above the air. If you do, I don't know what Ferris wheel you're riding. So it starts there, but it's still a cosine graph, so we still have to go along the pattern. So down, midline, up, midline, down. If we look, our graph is upside down. Since it's upside down, it's kind of flipped over the midline. That tells us that we are going to need to have a negative in front of the A. So I'm going to just mark that as a note here. It's flipped over midline or upside down, which means we need a negative in front of A. Okay, it told us to sketch just one cycle. One cycle was done, but we need to write that last point. That is your period, and it tells us it takes 8 minutes. to complete one cycle, so that is 8. Now let's go back so we can find the amplitude and we can find the frequency. So the amplitude, you could take your maximum or your minimum. I'm going to take the max and subtract the midline. Okay, so we have 130 minus 67.5. We get 62.5. So 62.5 is our amplitude. To get the frequency, we use our formula. P equals 2 pi over B. We know that period is 8 because it told us that that's the time it takes to complete one full rotation. So 8 equals 2 pi over B. We need to cross multiply, so put that over 1. We have 8 times B, which is 8B. We have 2 pi times 1, which is 2 pi. And then we divide both sides by 8 to solve for B. And we get B is equal to, we can simplify 2 over 8. It becomes 1 over 4. You can use your calculator for that if you'd like. And again, we don't need this one, so it can just stay as pi over 4. So now we have all 3 components. We can fill everything in our graph. So y equals, keep in mind, we need the negative because it's flipped over. Think about it in the context of the problem, okay? The person gets on a Ferris wheel at the lowest point, which is why we started the graph at 5 instead of 130. You're not getting on a Ferris wheel at 130 feet above the air, okay? You're getting on at the bottom. So that's why we need that negative. Our amplitude was 62.5. Then we have cosine. B was pi over 4. I'm so used to putting x. Pi over 4t plus the midline, which was 67.5. And this here is our equation. Okay, so there's going to be 2 check for understandings for this lesson. This is the first one. And this is the second one. Remember, you need to show all of your work to receive full credit. And once you've completed it, you are uploading a picture of your work and your solution to Google Classroom to get credit for this class. Okay, everyone, I hope you have a great rest of your day.